Welcome to this deep dive. We've got a stack of sources here, and we're going to unpack the really key insights for you.
That's right.
Today we're diving into, well, the accelerating world of artificial intelligence. We're looking at a pretty detailed analysis covering trends right up to early 2025.
Yeah. And it's got everything, user growth, infrastructure, the competition,
Yeah.
and, the huge impact AI is having on how we work.
Our goal here is really to cut through all the noise.
Mm.
This source is packed with charts, stats.
Mm.
It paints this picture of change that's just, well, the report calls it unprecedented.
Yeah, unprecedented speed. We want to pull out the data points, the ideas that really show you, the listener, just how incredibly fast things are moving.
Okay, so let's get right to the core message here. The analysis literally asks, seem like change happening faster than ever?
And the answer?
Yes, it is. It flat out describes AI user growth, the usage, the capital expenditure, all as unprecedented, capital U.
And, maybe the clearest example of that speed is just how quickly people started using this stuff. I mean, look at ChatGPT.
Right.
The company's been around 9 years, sure, but the user ramp up, the source calls it history's biggest overnight success.
5 days. To get to 1 million users, that's almost hard to grasp.
It is. And then scale that up. By April 2025, they're talking 800 million weekly users.
So put that in context for us. How does that compare to, say, the internet?
Well, think about the internet itself. It took something like 23 years to hit 90% global penetration.
Okay.
But if you zero in on USA-based large language models, specifically their adoption outside North America, they had 90% penetration among mobile app users in just 3 years.
3 years versus 23.
Exactly. It's not just faster. It's like a completely different phenomenon. It's exponential growth.
And the analysis points out another really key difference, doesn't it, about how it spread.
Yeah, that's crucial. Unlike the early internet, which kind of diffused slowly outwards from North America.
Right, I remember that.
AI tools like ChatGPT just landed everywhere, all at once, across most global regions simultaneously. It wasn't a slow burn. It was like flipping a switch worldwide.
An immediate global thing. Okay,
Yeah.
so that kind of user explosion, it doesn't just happen, right?
Yeah.
Something has to power it.
Precisely. Which brings us to the engine room, as you might call it. The infrastructure.
The plumbing.
Kind of, yeah, but maybe more like the power plant. We're talking about capital expenditure, CapEx, the money the big tech companies are spending. It's fundamentally changing because of AI.
And not just changing, it's surging. The analysis shows the big 6 U.S. tech companies, their CapEx is up, what, 63% year over year?
Yeah, a massive 63%, hitting $212 billion by 2024.
$212 billion.
But here's the really interesting part, I think. It's not just the sheer amount of money, which is huge. It's where that money is going.
Oh.
They're shifting focus. It
Yeah.
used to be about building the basic internet pipes, storage, distribution, access.
Right, the plumbing we mentioned.
Exactly. Now, the CapEx is moving aggressively towards building the brains. It's all about computation, intelligence, specialized chips, these huge new frontier data centers designed just for AI.
Data centers are really ground zero then.
Absolutely. Look at the construction value for data centers in the U.S. It's accelerating like crazy 49% annual growth over the last 2 years.
And there's that anecdote in the report about the XAI Colossus data center.
Oh, yeah, that one's wild. Built in 122 days.
122 days for a massive supercomputer center.
Yeah, 750,000 square feet. That's like, I don't know, over 400 average American homes. And they built it in half the time it normally takes to build one house.
Wow. That just screams urgency, doesn't it?
It really does. It shows the incredible pace of this infrastructure build-out. They need this compute power, and they need it now.
But all that compute, it needs juice, energy. The analysis highlights the data centers already accounted for, what, 1.5% of global electricity use in 2024?
Yep, 1.5%. And that number's been growing globally around 12% per year since 2017.
12% growth per year is pretty significant.
It is. And here's a key point. 45% of that global data center electricity consumption is concentrated right here in the USA.
45%, so nearly half.
Exactly. And the analysis suggests this is becoming a bottleneck. AI progress isn't just limited by data or algorithms anymore. It's hitting limits in energy availability, grid capacity. Energy is becoming like a really critical strategic factor for AI development.
Okay, so massive investment in data centers, huge energy needs. Who's really benefiting from this hardware boom?
Well, the chip makers, obviously. And one name stands out, NVIDIA.
Right.
Their data center revenue, It's already 25% of the entire global data center CapEx spend, and it's still climbing.
25%.
Yeah. And the report mentions their installed GPU computing power has seen something like over 100x growth in just about 6 years.
100x. That's just an incredible scaling.
But it's not all NVIDIA. The big players are also making huge bets on their own custom chips.
Ah, right, like Google's TPUs.
Exactly. Google's TPUs, Amazon's Trainium chips, these are foundational bets. They're designing silicon specifically tailored to run their AI models as efficiently as possible. It's about performance, sure, but also about the economics.
Better price performance, I guess.
That's the claim. Amazon, for instance, says their Trainium 2 chip gives them like 30–40% better price performance compared to standard GPUs for their tasks.
Okay, that makes sense. Which brings us to the economics of all this compute.
Yeah.
Training these huge models.
It's expensive, right?
And getting more so.
Oh, yeah. Hugely expensive. The analysis estimates training costs have shot up something like 2,400 times over 8 years.
2,400x.
Yep, and it could hit over $1 billion for a single training run soon. They cite Anthropic's CEO on that.
$1 billion to train one model. Wow.
But here's the paradox. While training costs are skyrocketing, the cost to actually run the models once they're trained, the inference cost per token is plummeting.
Falling dramatically. How dramatically?
Get this. The analysis says an NVIDIA H100 chip uses 105,000 times less energy per token compared to a chip from back in 2014.
105,000 times less energy. That's an insane efficiency gain.
It's exponential. And this is where you see that classic tech cycle kick in. The analysis calls it the perpetual aha.
The perpetual aha. Okay,
yeah.
Explain that.
It ties into something called Jevons paradox.
Right, I've heard of that. The idea that making something more efficient doesn't always reduce consumption.
Exactly. Because it becomes cheaper or easier, you find new ways to use it, unlocking demand you didn't even know was there. So overall usage actually increases.
So the perpetual aha is that loop. Costs drop, performance jumps.
Which makes new applications possible, driving more usage.
Which fuels more investment and further breakthroughs.
Precisely. It's this continuous feedback loop where efficiency gains unlock explosive growth. And that's powering AI capabilities way beyond just, basic chatbots.
Okay, so where are we seeing that capability growth?
Well, first, model performance itself is just converging upwards really fast. Top models are getting way better on benchmarks like MMLU. That's a test of general knowledge and reasoning.
So they're getting smarter, basically.
Smarter, more accurate, and also more realistic. The report mentions a Turing test simulation in March 2025.
The Turing test, judging if it's human or AI.
Right. In this simulation, testers mistook the AI for a human 73% of the time.
73%, that's quite high.
It is. Add to that the incredible realism we're seeing in AI image generation. They mentioned Midjourney examples, and you just see how sophisticated these things are becoming.
And it's not just text or images in isolation anymore, right?
No, that's a huge shift. We're moving rapidly into multimodal AI.
Meaning systems that handle different types of data.
Exactly. Text, images, audio, video processing, and integrating all of them seamlessly. The analysis notes a crazy jump, a little 1,150% increase in the release of large-scale multimodal models in just 2 years.
Over 1,000%.
Yeah. Think models like GPT-4o, Claude 3. They can understand and generate across these different modes.
What does that mean practically?
Well, the analysis gives examples like a field engineer pointing their phone camera at some machinery and getting an instant diagnosis from the AI.
Okay, I see.
Or a doctor attaching an X-ray image to a patient note and having the AI draft a report incorporating both. It cuts down on switching between tools and lets the AI understand richer context.
That makes sense. More natural interaction.
And building on that, we're seeing the rise of AI agents.
Agents, how are they different from, say, chatbots?
The analysis describes them as less assistant, more service provider. It's moving beyond simple Q&A. These are becoming intelligent, long-running processes.
Meaning?
They can understand more complex goals, remember things across interactions, plan steps, and even coordinate actions across different apps to actually do things for you.
Yeah.
Get real work done, as the report puts it.
So, like a little autonomous worker.
Kind of, yeah. And public interest is definitely picking up. Google's searches for AI agent are up over 1,000% in just over a year.
Wow. Are companies actually using these yet?
Oh, yeah. It's moving past just experiments. You've got Salesforce with Agentforce, Anthropic building agent-like capabilities into Claude, Amazon with something called Nova Act. Enterprises are starting to deploy them. The way we interact with AI is shifting from just prompting to actually assigning tasks.
Okay, this is fascinating. But the report also talks about AI moving beyond the digital realm. right? Into the physical world.
Yes, and this is a really significant step, the rise of physical agents. AI intelligence isn't just staying in our computers and phones.
Where's it going?
Into vehicles, machines, defense systems, manufacturing, things that move and interact with the real world.
Like self-driving cars.
That's a prime example. Tesla's full self-driving. The cumulative miles driven went up nearly 100x in less than 3 years.
100x miles driven.
And in places like San Francisco, Waymo, Google's self-driving car company, already had a 27% share of the rideshare market by April 2025.
Yeah.
These aren't just test projects anymore.
They're part of the transportation system.
Right. And it goes way beyond cars. Defense companies like Burrell, using AI in their systems, saw revenues double year over year.
Okay.
In agriculture, there's a company called Carbon Robotics with a laser weeder, uses AI vision and lasers to zap weeds. It's already weeded over 230,000 acres.
Weeding with lasers, that's pretty sci-fi.
Isn't it? And in mining, Cobalt Metals is using AI to analyze geological data and predict where to find mineral deposits. It's changing how resource discovery happens. AI is becoming kinetic. It's actually controlling physical actions.
So with AI getting this capable, this integrated, physically and digitally, what's the impact on work, on knowledge?
Well, the analysis frames it as a fundamental shift driven by cognitive automation.
Cognitive automation, okay. What does the data show about jobs?
It's pretty stark, actually. Looking at the U.S. over the last 7 years or so, up to April of 2025, AI job postings are up 448%.
Wow, nearly 450% increase.
But at the same time, non-AI IT job postings are actually down 9%.
Down 9%. So a clear shift in demand for skills.
Definitely. And employers are catching on fast. About 7% of U.S. firms were using AI in the first quarter of 2025. That sounds small, but it was up 21% from just the previous quarter.
So adoption is accelerating quickly among businesses too.
Yeah, and their main focus, productivity, boosting internal employee productivity, finding ways AI can handle tasks done by specialized, expensive workers.
Are they actually seeing those productivity gains?
The report sets examples, yeah. Like a 14% productivity increase in customer support roles using AI tools.
14% is pretty substantial.
It is, and you hear this urgency echoed by CEOs. The analysis quotes Shopify's CEO, Tobias Lütke, telling his team basically, stagnation is failure. If you're not climbing, you're sliding.
That's intense.
It is. And maybe even more direct is Louis Van On from Duolingo. He declared Duolingo is going to be AI first.
AI first, what does that entail?
Things like mandating AI use in hiring, in performance reviews, even putting headcount constraints on teams if AI could potentially automate their work.
Wow. So they're really pushing it hard.
Yeah, the analysis suggests leaders like him feel they have to move incredibly fast, even if it means accepting some small dips in quality initially, rather than risk moving too slowly and just missing the boat entirely.
That makes sense given the speed we've been talking about. How does this change how we think about knowledge itself?
The report traces this neat evolution. Think about it. First, we had static plus physical delivery, the printing press, right? Books.
Right, 1440s.
Then came active plus digital delivery, the internet, from 1993 onwards. Information became dynamic, instantly accessible.
Okay.
And now, with tools like ChatGPT emerging in 2022, we're entering an era of active plus digital plus generative delivery.
Generative, meaning the AI creates the knowledge or response on the fly.
Exactly. It's not just retrieving information, it's synthesizing, creating, explaining. And critically, it's leveraging all that internet infrastructure that came before, which is why the adoption is wicked fast, as the report says.
Compounding.
Precisely, which has really interesting potential implications for global internet access.
How so?
Well, there are still, 2.6 billion people offline globally?
Yeah, a huge number.
But technologies like satellite internet, Starlink is the big example here, are making access possible in places it never was before. Starlink hit 5 million subscribers by early 2025, showing like 200% annual growth.
So more people coming online, faster.
Right. But here's the kicker. The analysis suggests that when these new users come online, maybe their first interaction isn't with a web browser or a search engine.
What then?
They might jump straight to interacting with AI agents in their own language, getting answers, getting things done, maybe skipping over layers of traditional apps we take for granted.
That could really change the global digital map.
It could. But all this speed, all this capability, it also creates a really intense competitive environment. The analysis calls it the AI race.
Okay, the AI race. What are the key dynamics there?
Well, there are definitely challenges for the current leaders, rising competition, the growing strength of open source AI, and significantly, the strategic competition with China.
Right, the U.S.-China dynamic is central here.
Absolutely. The analysis frames it almost like a new space race, but for AI dominance. And the stakes are potentially world order shaping.
How is China approaching it?
They're really accelerating focus on strategic sectors like AI, through initiatives like Made in China 2025. They're integrating AI into their military, pushing for indigenous innovation to be less reliant on foreign tech.
And there are concerns about how AI might be used differently.
Yeah, the report mentions worries, like those from OpenAI's Sam Altman, about potential data sharing, surveillance, under AI systems developed within more authoritarian frameworks.
And the public perception is different too.
Massively different. In China, over 80% of people apparently see the benefits of AI. In the US, it's only around 39%.
That's a huge gap.
It is. And it suggests that choices about which platforms to use, how AI gets adopted, might become increasingly tied to national identity, values, geopolitical alignment.
What about the open source factor?
That's another huge dynamic. Models like Meta's Llama, DeepSeek, they're getting really, really good. The analysis says their performance is closing the gap with the big closed source models like GPT-4.
And they're cheaper, presumably.
Often, yeah. Or at least more accessible, more customizable for developers. Meta's Llama apparently hit over 1 billion downloads by April 2025.
1 billion downloads.
Yeah, and Meta's CEO is quoted predicting that open source will actually be the dominant type of model developers use in 2025. That really shakes things up.
So, okay. Massive investment, intense competition, open source rising. How does anyone make money in this? Monetization. Ugh. The billion-dollar question, maybe literally. The analysis is pretty clear. The economics are still figuring themselves out. It's driven by that huge capital intensity we talked about earlier, the chips of the data centers.
Right.
So even with the crazy growth in users and usage, the path to consistent, widespread profitability might still be a long way off for some.
But some parts of the ecosystem must be making money now.
Oh, for sure. Certain segments are seeing really rapid revenue growth. Think about the specialized cloud providers focused just on AI compute, like CoreWeave. Their revenue was reportedly up 730% year over year.
700%, okay.
Companies providing core AI infrastructure, like Oracle AI or Astra Labs doing the connectivity stuff, they saw revenue growth over 240% year over year.
That's still massive growth.
Absolutely. And companies managing the crucial data pipelines and supercomputing needed for training, like Scale AI, they reported 160% revenue growth in 2024. So the picks and shovels, they're doing well.
The enablers? What about the big tech companies themselves? How are they monetizing?
They're leveraging their biggest asset, their massive existing user bases. Billions of people across Meta, Google, Microsoft, Apple, Amazon.
Right.
They're rapidly rolling out integrated AI features into the products people already use every day. Meta AI is embedded across Facebook, Instagram, WhatsApp, nearing 1 billion monthly active users already.
1 billion users for Meta AI.
Microsoft Copilot is seeing billions of chats. Google's pushing Gemini and AI overviews into search and everything else. Apple, TikTok, Spotify, Canva.
Yeah.
Everyone's baking AI in.
And what about business software, enterprise size?
Deep integration there, too. You have the big incumbents, Microsoft with 365 Copilot, GitHub Copilot for developers, Adobe with Firefly for creatives, Zoom adding its AI companion Canva, Salesforce with Agentforce. They're putting AI right into existing workflows.
Makes sense for them.
But what's maybe even more telling, I think, is the explosion of specialized AI software companies.
Focused on specific industries.
Exactly. Software engineering tools like AnySphere Cursor, healthcare tools like Abridge for clinical notes, Harvey for legal work, Decagon, AlphaSense for finance and market intelligence, customer service bots.
That are growing fast.
Incredibly fast. The analysis highlights some really impressive annual recurring revenue ARR growth stats for these players.
ARR, that key subscription metric.
Right. We're talking companies going from maybe $1 million ARR to $50 million or even $300 million in just months or a couple of years. These specialized companies are just soaking up AI innovation and automating very specific high-value workflows in their particular industries.
So the impact is becoming very real, very specific across the board.
Absolutely.
Okay, so let's try to zoom back out. We've covered a ton of ground. What's the big takeaway here?
I mean, it really comes back to that first point, doesn't it? The pace of change with AI. This analysis makes a strong case that it truly is unprecedented.
Yeah, that seems undeniable from the data.
It's fueled by just staggering infrastructure investment, these incredible leaps in technology like the falling cost of inference, the rise of multimodal AI, these agents,
And it's not just digital anymore. It's transforming work, physical systems.
and maybe even how billions more people connect to the internet for the first time.
And the competitive landscape is intense.
Super intense. You've got the US-China dynamic, the rise of very capable open source models challenging the closed ones. It's a real race.
The analysis mentions risks too, right?
Yeah.
Misuse, uncertainty.
It does, yeah. It acknowledges those serious risks. But it also strongly emphasizes the immense potential for positive impact, especially in areas like accelerating scientific discovery,
Yeah.
improving healthcare.
So to wrap up, maybe leave our listeners with a final thought from the source material.
Yeah, there are a couple of powerful ones in there. How about this? The report suggests in the next decade or two, imagining a world without AI will likely feel the same as imagining a world without the internet.
Wow. That really puts it in perspective. Or there was that other line.
Ah, yes. Innovation is not just a business advantage, it is national posture.
National posture. That ties back to the AI race idea.
Yeah.
What does it really mean for all of us, for you listening, as AI stops being this novel thing and just becomes part of the fundamental infrastructure of our world?
Yeah. What stands out to you from all this?
We hope this deep dive gave you some things to think about, some real insights into just how fast the world of AI is moving. Definitely share this if you found it useful. And please, subscribe to the deep dive wherever you get your podcasts so you don't miss our next exploration.